discussion on the question of building a European hydrogen infrastructure. My name is Tim Kehler. I am the CEO of the German Gas and Hydrogen Association, called Zukunft Gas. Our focus is the transformation of the gas industry into the future hydrogen industry. And this, of course, is also about the transformation of the infrastructure of the current natural gas infrastructure. Why is it so important that we talk about infrastructure in this hydrogen context? To our core belief, we are focusing on two pillars to develop a future hydrogen economy. One is the tradability of hydrogen. We need to develop systems in markets. We need guarantees of origin. We need global value chains where trade and free markets can unleash their power to create efficiencies in the markets. And secondly, to make the product tradable, we need the right infrastructure. So there's no hydrogen market without the infrastructure, and our core belief is the infrastructure for hydrogen in the future will develop out of the existing natural gas infrastructure, which consists out of pipelines, storages, ports, and whatever you need to transport energy in the form of gas. To start the discussion, and I'll introduce my panelists right afterwards, we have prepared a little poll just to test what you think about the infrastructure. If we could see the first question, and please have a look at it and give us your perspective on is the majority of the European natural gas grids and storage facilities hydrogen ready? Is the technical basis there, yes or no? Or you don't know? Please vote now. Okay, it's a race, so it's no shame if you say you don't know it, because many don't know it. Even we don't know it in many cases. To bring my first panelist on stage, Dirk Manske. He is Head of Regulatory Affairs and Energy Policy at Ontras Gas Transport, the leading East German TSO, the transport system operator with the big pipelines transporting gas and the future hydrogen. You can visit also the nice stand right around the corner. What is your view on this question?
Well, thank you very much for the introduction. Thank you much for the invitation. It's a pleasure to be there. I think the responses fairly reflect the current state of the discussion, really, about this topic, whether or not the existing gas grid is already ready. It depends on what you mean with ready. Generally speaking, we can use the existing net, we can use the existing pipelines, the gas pipelines, for hydrogen. That's pretty clear. But we can't just say we inject hydrogen from one day to another into the grid and then we can start using it with hydrogen. That doesn't work. So we have to do some preparatory work. We have to conduct some investment. We have to analyze the pipelines. We have to analyze the grid. And actually, we at Ontras, we're currently doing it because we're making the first pipeline, I think it's the first pipeline in Germany, ready by the end of next year. It's part of a project, Energy Park Bad Lauchstädt. We've started the works on this pipeline. It's 40 years old. So you clean it, you make a technical assessment, and then depending on the results of the technical assessments, you have to do this or that with the pipeline in order to make it fit for purpose. But generally speaking, yes, you can use the existing gas grid, and what you have to do in order to use it depends on each individual pipeline.
That's a fairly positive outlook. So we seem to have at least major parts, building blocks of a hydrogen infrastructure in our hands. It's an asset. Coming to Katharina Umpfenbach, you're director with the German Energie-Agentur, dena, responsible for infrastructure and energy systems, and your core focus is on planning energy systems. Before we start in your thoughts on how to develop a climate-neutral energy system, maybe you can explain us why do we need the state for planning at all?
Well, infrastructure, we're dealing with a monopoly here, a natural monopoly. So one key element, I'm not an engineer, so I totally trust you with the technology, but the other ingredient that we need is regulation, right? So we must make sure that those grids to have investment decision, that these investments can be refinanced through grid fees. And in this process, the state is involved in form of the federal regulator who signs off, let's say, on the planning, and so also signs off on the grid fees that then allow those investments to be recouped. So the state is involved very much. Maybe I can say a little bit more about the integrated planning.
Yes, please. So we can confirm the state has a role to play in order to make it efficient and to avoid monopolies.
Well, and to allow the investment actually, yes, to be refinanced. And the other aspect, and that's why where my work focuses on the moment, is that with the hydrogen grid, but with the whole energy transition really, what we're seeing is that the different infrastructures we have in the energy field, so gas, the future hydrogen grid, power grids, and on the local level also heating grids are more and more integrated. And one key technologies that we all know is the heat pump and the electric vehicle, but the other one that's more interesting in our context here is the electrolyzer, which is a key flexibility element to take up renewable energy on days where we have lots of it, more than we need, and then a vehicle with the hydrogen to transport it, although to other regions that might not have locally a big renewable energy potential. So this integration, we think, or the government thinks, needs a planning process where those things are more integrated than they used to be in the past.
Dirk, last week we heard about the proposal that Germany is planning something that was initially named as the starter grid, now is the core grid for hydrogen. Can you give us some insights what's happening there, and particularly what is Ontras planning in this context?
Well, it's a very important process that it's an informal dialogue. I mean, between the government, the regulator, and the industry, and I mean the grid transport industry. And it's a dialogue about what do we need first in order to get it going with the market ramp up for hydrogen. Everybody knows we need to have a transport grid. It's an enabler for market ramp up because it connects demand.
For those who are not in the depth of the regulation, what's the difference between a transport grid and a distribution grid?
Well, transport is over longer distances, and the distribution grid brings the gas directly to the end customer. So we bring it as a gas transport company. We bring the gas to large-scale consumers, few large-scale consumers, but mainly we bring it to distribution network providers who finally bring it to you as the end customer. So that's the distinction between distribution and transport. So coming back to the grid that we need, I think there's consensus. We need to have some kind of a starting grid in Germany in order to get the market going. The question was always, or has always been, how we get to this grid. And what we're discussing now with the government, with the regulator, is that we set up a process in which we, as the transport grid industry, makes a proposal of how a future grid could look like in order to satisfy demand, immediate demand, but also longer-term demand, and which satisfies the need in order to have a rollout, a market ramp up of the whole hydrogen sector. We want to make this proposal. For this, we need some legal requirements. We need some things in place, which the government is eager to provide, and they have come up with a draft legislation for this. Once we table such a proposal, the regulator then will closely inspect it, will look at it. Does it fit to the general energy and climate goals that the government has? Does it satisfy the needs of the market? Is it too big? Is it too small? And so forth. So they're going to check it. And finally, they give their green light. In between, there's consultation with all market participants which are affected by the grid, which need the grid for their own purposes. So that's the idea of the whole setup. And we've started this dialogue informally, and it will become a formal dialogue in a couple of weeks, in a few months probably, because it's enshrined in legislation which is now going through Parliament. And we expect to have a decision about a starting grid, a core net as it's called now in Germany, by sometime around October, November. That's, as far as I understand it, the plan of the government at the moment.
So there are probably many persons interested in the audience in participating in this process. Where should they direct the requests, or where can they obtain information on this, on the details of this process?
Well, if you're interested in it as in terms of or in your capacity as a market participant, the right time to get involved really is formally get involved is once there's a consultation about this proposal for a core grid. I don't know exactly when it will be. That depends on the future process, but it will be probably sometime September, October, maybe a little bit later. So there's an official market consultation. That's the time where everybody in the market can participate and give his or her opinion on whether this grid satisfies his or her needs and the general needs of the economy. If you're generally interested, if you're a producer of hydrogen, if you're a prospective consumer of hydrogen, so if you're generally interested in transporting hydrogen, I would just ask you to approach us as a company, come to our stand, get in touch with us, and then we could discuss the details of what's possible, what are your needs, how's the planning going on, how's the process going on forward. We have a stand outside, and we're happy to discuss those details with you.
Katharina, talking about the planning process, you have to integrate all the different perspectives, electricity grid, gas grids. One key question is, of course, where do you place the electrolyzers? Interesting question, I think, to many of us. Also, the other question is, well, we do not only plan it top-down from the perspective of the building up of renewables, but we also have to cater the needs of power plants, of industrial plants. How do you integrate all these different interests, and what's your perspective on, particularly also the electrolyzer question?
Yes. Well, let me say a few words about the process. So, this what we call the system development strategy. That's the goal. So it has one first element, which is a vision, a strategic vision of how the energy system in total, so not only the infrastructure, but also all the demand sectors and all the technology development could look like in 2045. Obviously, in line with the climate goals of the German government. And then what the ministry did, they asked their modeling or a big modeling consortium to see if we just optimize for costs. So not look down really from the top, what would be the effective investment decisions over time, both in infrastructure and also electrolyzers, electric vehicles and renewable energies, everything. And what you see, for instance, to answer your questions on the electrolyzers is, of course, if you optimize for cost, then for the whole energy cost, for the whole system, they end up in the north of Germany mostly. Because in any case, we have a massive increase in power grids already, in power transport grids, to fulfill the electrification demand that we're seeing in the demand centers. So if we also build the electrolyzers in the south, these costs go even further up.
But when I own an industrial company in the south of Germany, do I have to move to the north then, or what's my future?
Yes, so that's the question that you said about how do we put this sort of top-down vision together with demand. So what we're doing is we have a stakeholder process where all the key industry players, but also societal players like environmental NGOs, representatives of cities and so forth, are looking with us together on those results and discuss exactly those issues. So I think one thing is important is that we will repeat this process every 3 or 4 years. So there is some uncertainty, and that's acknowledged. To talk specifically about the industrial center in the south, of course, the idea is that they then get hydrogen via a pipeline. That's sort of the optimal outcome that the scenario provides.
How much state is needed there? I could envisage that we have an electrolyzer company in the north, which found a industrial customer in the south. Can they build their own pipeline on their own behalf?
Well, good question. Probably if they manage to raise the investment for that, which I doubt. I think it's pretty clear that this sort of is the long-term outcome, right? So in the build-up, the process will be more, we will see sort of winding lines, and we might see some electrolyzer capacity in the south as well, especially in sort of until everyone is connected. This is very much the idea to think about cost optimization in the long run, and then the result is different.
We now had to focus on German infrastructure and German regulation. However, when we're talking about hydrogen, we're talking about a global business. We anticipate that a lot of hydrogen will be imported from global sources within the EU, outside of the EU. You've been involved also in European projects. So what is going on there, and how do you envisage a European hydrogen backbone?
Well, thank you. I think that's a very important question, because we can't conceive hydrogen network or hydrogen infrastructure just from a national point of view. And it's important to connect our economy, our hydrogen economy, to those of our neighboring countries as well. And the reason for this is that it's simply much, much more efficient. So we have been a member, as Ontras Gas Transport, we've been a member of the European Hydrogen Backbone, which is a network of gas transport companies like us, by now 31 gas transport companies from 28 countries in Europe. And we've developed a vision for a pan-European hydrogen net which crosses the borders. That vision has started in 2020, and we've further developed it by now. It's now a vision which, if we realize it, would be able to transport the amounts of hydrogen foreseen by the European Commission in their Repower EU strategy. And I think the important point there is that such a trans-European, pan-European network allows us to produce hydrogen where it's produced most efficiently, which will be to some extent in the south of Europe. It may be to some extent in the north of Africa. It may be to some extent in Scandinavia, or to a considerable extent in Scandinavia. And maybe, hopefully, to some extent also after the end of the war, after it's rebuilt in Ukraine, as an example. So there are a couple of potential sources for cheap hydrogen, because these countries have huge potentials. And if we have a connected grid which really spans the whole of Europe, then this allows us to produce it where it's cheapest and to import it. Because one point will be clear: in Germany, even though we have to increase the capacity for renewable energy, and we're doing it, we will not be able to produce all the hydrogen that we need by ourselves. We need to be reliant to some extent from import sources, and that grid will help us to do that. But grid is not only, last sentence on that, we also need a transport infrastructure, we need a storage infrastructure. Storage will be crucially important for balancing demand and supply, and we also will have an import infrastructure at ports, for example.
To add to the point on the European Hydrogen Backbone project, which is a joint project of many European TSOs, such as Ontras and others, you also did extensive technological research. And if I look at the questions that we have, there's still many questions on the technical aspects. There have been quite intensive technical undertakings also to understand, are the materials ready, hydrogen ready, and what needs to be done to convert it. The outcome was positive, wasn't it? So the answer is yes, we are hydrogen ready.
Yeah, the outcome is generally positive. As I said in the introduction, you have to look at each individual pipeline in order to make an assessment whether or not you just can use it right away or whether you have to do something. Generally speaking, new pipelines are fit for purpose for natural gas and hydrogen as well. The question is, what are you going to do with older pipelines? We, for example, the first pipeline we start with to convert, to repurpose from natural gas to hydrogen is 40 years old. Yeah? And we chose such a pipeline in order to understand better what's the impact, what's the state of such a pipeline.
But the tests done by technical departments clearly show the steels are ready. They don't show brittling under hydrogen.
Steels are ready, but you may have to do things. You have to replace fittings.
And,
you have to replace the compressors. And we as Ontras, we will start our grid without compressors, our hydrogen grid. But at some time when there's a significant amount of hydrogen in the system, you need compressors. They have to be new. Fittings have to be new. You may have to do some type of internal coating of the pipelines. That really depends very much on the pipeline. But the point is always, you can convert it. You just have to find out what you have to do in order to convert it.
Same, by the way, applies to the distribution grid, 500,000 kilometers, which are mainly polyethylene, which doesn't leak any hydrogen. So we have a real treasure, a big asset in the ground in Germany, in Europe, I think, in vast areas, where we can say we can distribute hydrogen to a large extent. So big work for regulation. We briefly touched on one issue. Storages. How do you integrate also storages, gas storages, which will be hydrogen ready, or batteries, or whatever else could be envisaged into such a planning process?
Yeah, the key issue. So in our process, it became clear that hydrogen storage is absolutely a key technology for the whole system to work, to provide especially the backup then in days of, long days of lower renewable output. So absolutely a key technology. And one problem in the planning, or a challenge in the planning, is that for now we still need them as gas storage units. So if we convert them, the timeline is also an element of coordination that we need to get right. And at least in the modeling done supporting our strategy, it's clear that we also need some new builds.
Talking about timing, I would like to ask for the second poll that we have prepared that should provide us with your assessment on the speed of change of the infrastructure. So, what is your expectation? When will we see will we see the first hydrogen pipelines? In the next 3 years, or never? Well, I think you made a good job, Dirk, in telling the audience, yes, we are in vast areas of the grid hydrogen ready, and we can start quickly. Will we be that quickly?
Well, we're talking about the first pipelines, and I think it might be possible that we're going to see the first pipelines. I just mentioned one of our core projects at the moment, the Energy Park Bad Lauchstädt, where we will repurpose a specific pipeline. That will be done by the end of 2024. That's the plan, at least. I think with that we're going to...
But Lauchstädt, you will also integrate the storage.
Yeah, exactly. But Lauchstädt is the energy
business.
park is a whole value chain park which integrates the wind power. We have an electrolyzer currently, probably with a capacity of some 30 megawatt. We're going to include storage. It will be a salt cavern that is going to be transformed for storing hydrogen. And we're going to have the pipeline. So it's going to be the first project ever which comprises the whole value chain. That's a real laboratory. In other words, it's, for the time being, it's rather small scale, but it's a start from which we can learn. As regards our starting grid in Eastern Germany, that's the region where we operate our network, we plan to have our starting grid, which is going to be about some 950 kilometers, ready by sometime 2027, 28. And we're going to be among the first. I don't know whether there's anybody who's going to be faster with a pipeline than we. But that means more or less, yeah, within 3 years, we're going to see the start of it. but the bulk of the pipelines, the bulk of the network will be developed sometime in the next 5, 6, 7 years.
Maybe I can come back
Would
to
the
this.
regulation be
Yes.
as speedy as the pipeline guys?
Oh, well, I hope so. I think we have made a big step forward this year, or we are in the process of making a big step forward. And yes, so yeah, I think so. Otherwise, it's not going to happen. So 2030 is, I mean, just around the corner. 2030 is when we have our key next climate goals to reach. So that's a key element for that, to reach it.
As a regulation expert, and that's what infrastructure is about, regulation in Europe, if you compare internationally regulation methods and the maturity of infrastructure, particularly for hydrogen, if you look at the US or other areas in the world, are we on a good pathway here? Do we have a good starting point? When I talk to my US colleagues, particularly on IRA, they are quite happy about the very high tax incentives that they receive for hydrogen production. However, they say, what does it help me when I produce electricity or hydrogen in South Dakota and I don't have a grid, electrical grid or a gas grid to bring it away? So is that an advantage that Europe has?
Well, if we look at the power grid, I think where we have more experience already in integrating EU-wide, I think it's been an absolute success story. That's not very much told, actually. I mean, and the same for the gas grids, which saved us last year. I mean, the fact that we had other connections than to Russia was really key for us to have warm houses. So I think Europe has a good track record of integrating across borders, and I want to underline that this is a key element for the hydrogen part. But obviously, we are different nation states with different regulatory cultures, and well, the dena perspective is that we need quite a lot of dialogue along those corridors to make sure that on each sort of, once we cross the next border, the regulation is at least compatible with each other. And one key element that we need for that is EU regulation.
In this context, I would like to call a question from the audience, rightly asking also after the distribution grid, which was not in the focus of our current discussion, but how will the integration of the distribution grid, which connects most of the customers actually to the gas grid, develop?
That is a very difficult question. Well, I have to say, well, I can just give you what the model underlying our strategy says. If you look at the long-term optimization, then you see quite a lot of electrification. So we will not have exactly the same scale of the distribution grid that we have today for gas, for hydrogen. But on the other hand, we have a lot of industrial customers that are connected to the distribution grid. So parts of the distribution grid need to be repurposed to also serve those customers with hydrogen if they can't electrify completely in their production. So I think that's the next step, and the EU regulation in this case is key. That's the key element, I think, also time-wise. We will have to see what the rules will be, who can operate hydrogen grids in the future.
A good question from the audience: can I privately build my connection to the TSO pipeline?
I would defer that question to you. I don't think it's possible without permission.
In any case, leave the connection to the grid to the experts. Don't do it
exactly.
Yes, please. Yes, please. You need permission to do that. I mean, generally speaking, so far the German market for hydrogen transport is organized as a competitive market. You can have non-regulated companies building their own pipelines. That's possible, and you have players in that market. You have companies such as Linde, such as Air Liquide, which have been involved in the transport of hydrogen at a smaller scale for a long time already. So generally speaking, it's possible that not only regulated grid or gas transport companies build it, but obviously you have to comply with all regulations in order to do it.
And there are quite some safety concerns,
Absolutely,
sort of
absolutely.
impacts on communities and so forth. So it's not like
I would like
not
to
only a financing question.
To come to an end, our time is over, unfortunately. But let's wrap up. What have we learned? So we have a grid which is able to deal with hydrogen. We need some changes, but these are minor changes given the breadth of the grid that we have. We are working on the regulation, so hydrogen will come eventually. We also have learned regulation is a fairly tricky and complicated business, but it's certainly important to watch. And we have learned we will see hydrogen pipelines very soon. What we have not talked about today is also an important aspect of the infrastructure, ports. We will discuss that tomorrow in a separate session. All the aspects coming overseas to us will come through ports and then injected into the grid. Big hand to our two panelists. Thank you for the lively discussion and the many questions that we have received.